Here is the problem almost everyone runs into with AI coding tools. You type a tiny message, maybe just, "Can you fix this bug?" That message might only be around 50 tokens. But Claude is not only processing that one sentence. In a real Claude Code session, your short message can sit on top of system instructions, project instructions, tool context, file reads, command output, conversation history, and sometimes thinking tokens. So when the bill feels larger than the words you typed, the right question is not, where did the hidden magic cost come from? The better question is, what else was inside the request when Claude answered? By the end of this video, you will understand what Claude tokens are, why tiny prompts can become expensive, and exactly how to reduce Claude API and Claude Code costs. A token is the unit of text a model processes. It is not always a full word. Hello might be close to one token. Hello, comma world can be several tokens because punctuation and spacing matter. A word like authentication may be split into smaller pieces. A paragraph might be 50 to 100 tokens. A code file can be thousands of tokens. This is why tokenizers matter. Code is especially token-heavy because it contains punctuation, indentation, repeated identifiers, comments, logs, stack traces, and sometimes generated content. The rule of thumb is useful, but do not budget serious production systems from guesses. Use token counting, inspect usage fields, and measure your actual prompts. The biggest beginner mistake is mixing 3 different Claude products into one billing story. Claude API is the raw developer API. You send a request payload and pay for token usage, plus any server-side tool charges. Your application decides which system prompt, messages, tools, and history are included. Claude Code is different. It is an agentic coding session. It can carry project instructions, claude.md, tool output, file reads, command results, skills, MCP context, conversation history, subagents, and background work. Claude.ai is different again. It is a subscription product with plan limits. A Pro, Max, Team, or Enterprise user experience is not the same thing as a raw API invoice. So keep these separate. The API is what you send. Claude Code is a coding agent session with extra context. Claude.ai is a plan-based product. For API work, most Claude costs come from a few buckets. Uncached input tokens are the normal prompt tokens. These can include instructions, messages, files, tools, and history. Cache write tokens are tokens you store in prompt caching. They cost more than normal input because you are creating the reusable cache entry. Cache read tokens are repeated cache tokens. They are much cheaper than normal input. Output tokens are what Claude generates. If thinking is enabled, thinking tokens are billed as output too, even when the visible thinking is summarized or omitted. Server-side tools can add extra usage charges. For example, web search and code execution have their own pricing rules beyond normal input and output tokens. In Claude Code, add one more idea: session context. The longer the coding session, the more prior context may affect future turns unless you compact or clear it. Now let us anchor the numbers. As of this recording, the official Claude pricing page lists Claude Haiku 4.5 at $1 per million input tokens and $5 per million output tokens. Claude Sonnet 4.6 is $3 per million input tokens and $15 per million output tokens. Claude Opus 4.7 is $5 per million input tokens and $25 per million output tokens. Prompt caching has separate pricing. A 5-minute cache write is 1.25 times the base input price. A 1-hour cache write is 2 times the base input price. A cache read is 1/10 of the base input price. Batch API can reduce input and output token cost for asynchronous work by 50%. But pricing changes. Before you publish a blog post, sales deck, or YouTube video, recheck the official pricing page. Treat every pricing table as a snapshot, not permanent truth. The pricing table is only the starting point. First, long context. Opus 4.7, Opus 4.6, and Sonnet 4.6 include the full 1 million token context window at standard per token pricing. That means a 900,000 token request is billed at the same per token rate as a 9,000 token request. But it is still 100 times more tokens, so it is still much more expensive. Second, data residency. On the first-party Claude API, US-only inference for Opus 4.7, Opus 4.6, and newer models can add a 1.1 times multiplier. Third, third-party platforms. AWS Bedrock and Google Vertex A. I can have regional or endpoint premiums. Do not copy first-party API pricing into a Bedrock or Vertex budget without checking. Fourth, fast mode. Opus 4.6 fast mode is a research preview that can be much faster, but it costs 6 times standard Opus token pricing and is not available with Batch API. Fifth, Batch API. It is cheaper, but it is asynchronous. It is excellent for bulk jobs, not interactive Claude Code loops. The surprise in Claude Code is not one secret prompt. It is session growth. A coding session accumulates context. At the start, Claude might have project instructions, tool names, and your first request. After a few turns, it may have file reads, bug explanations, diffs, test output, command results, and your decisions. After 30 turns, a tiny message like continue or fix it may sit on top of a large history. Important sources of cost include system and app instructions, claude.md, skills, MCP and tool context, conversation history, thinking tokens, tool results, subagents, and background Claude Code usage. Some of these are useful. Do not remove useful context blindly. The point is to inspect it. Use/usage to see session usage. Use/context to see what is filling the window. Use/compact after a milestone. Use/clear when switching to an unrelated task. Prompt catching is one of the best cost optimizations for repeated context. Think of it as write once, read cheap. For example, imagine a 100,000 token reusable prefix on Opus 4.7. Normal input at $5 per million tokens costs about 50 cents. A 5-minute cache write at $6.25 per million tokens costs about 62.5 cents. But a cache read at 50 cents per million tokens costs about 5 cents. So if the same stable prefix is reused many times, caching can save a lot of money and latency. But here is the catch. Prompt caching saves price, not context size. Those cached tokens still occupy the context window. If your cached prefix is huge, it can still crowd out useful context, even though it is cheaper to read. Use caching for stable prefixes. Trim context that changes every turn. Let us walk through simple examples. Example 1. A typical Sonnet API call. 12,000 input tokens at $3 per million is about 3.6 cents. 800 output tokens at $15 per million is about 1.2 cents. Total, roughly 4.8 cents. Example 2. A haiku extraction job. 100,000 input tokens at $1 per million is 10 cents. 2,000 output tokens at $5 per million is 1 cent. Total, roughly 11 cents. Example 3. An opus reasoning request. 80,000 input tokens at $5 per million is 40 cents. 8,000 output tokens at $25 per million is 20 cents. Total, roughly 60 cents, before tools or special modifiers. Example 4. A Claude Code style session. Suppose 30 turns average 60,000 input tokens per turn. That is 1.8 million Sonnet input tokens, or about $5.40. If each turn averages 1,200 output tokens, that is 36,000 output tokens, or about 54 cents. Before tool charges, thinking, cache effects, or background usage, the session is already around $5.94. These numbers are examples. The lesson is the shape. Input context dominates long sessions. Output and thinking dominate hard reasoning. Tools add their own layer. Do not optimize blindly. In Claude Code, use/usage for the current session. Use/context to see what is consuming the context window. Use/compact to summarize and shrink history. Use/clear when you are switching to a new, unrelated task. In the API, log the usage object, track input tokens, output tokens, cache creation input tokens, and cache read input tokens. Use the token counting API before expensive requests. For teams, use admin usage and cost APIs where available. Here's the practical checklist. Use Sonnet by default. Reserve Opus for genuinely hard reasoning. Use Haiku for extraction, routing, classification, and simple sub-agent tasks. Cache stable prefixes. Trim claude.md. Disable unused MCP servers. Avoid pasting giant logs. Use Batch API for asynchronous bulk jobs. Watch thinking budget and tool usage. Compact after milestones, and clear between unrelated tasks. The main idea is simple. Your bill is not only the sentence you typed, it is the full context Claude had to process, plus the output Claude generated, plus any tools or modifiers involved. Once you can see the buckets, cost stops feeling mysterious. Full written guide, pricing tables, diagrams, and checklist are linked in the description.